So basically in this question, we have a box that contains gold coins, and we know that if the coins are equally divided among 6 people, 4 coins are left over. If the coins are equally divided among 5 people, 3 coins are left over. And if the box holds the smallest number of coins that meets those 2 conditions, we want to know how many coins are left when equally divided among 7 people. So this is a very classic like modular arithmetic question. One way to solve this would just be a guess and check. Like you could technically guess and check. You could say, oh, suppose the box contained 1 gold coin. Does it satisfy the conditions? If not, let's check 2 gold coins. Does it satisfy? If not, we check 3 gold coins. Like you could do that, but like that'd be very time consuming, and like you don't have the time to like waste on the AMC. So like to do this question efficiently, we can like kind of use modular arithmetic. So remember how like modular arithmetic worked is like if you let x equal like the number of gold coins in the box, then we can kind of like set up a system of congruences kind of. So the first sentence, the second sentence technically says if the coins are equally divided among 6 people, 4 coins are left over. Essentially, what that means is if we were to take the number x and divide it by 6, we would get a remainder of 4. So in terms of modular arithmetic, what that means is x is congruent to 4 mod 6. So remember what this like kind of means is like x and 4 leave the same remainder when divided by 6. This like 3 lines is like kind of like an equal sign, but like it's actually a congruent sign. It just means that 2 numbers leave the same remainder when divided by this number here. So that's just refreshing your memory on what like modular arithmetic notation is. And the second condition, if the coins are equally divided among 5 people, 3 coins are left over. So in terms of modular arithmetic, that would mean x is congruent to 3 mod 5. So if the coins are divided among 5 people, you would get a remainder of 3. So basically that translated to math, that would be x is congruent to 3 mod 5. So now we can like kind of use the modular arithmetic tricks that we talked about last semester. Basically remember like we kind of like do negative numbers. Like with mods, we can kind of convert to negative numbers. So like this x is congruent to 4 mod 6. Like I can say technically, I can say like, right, I can say 6 is congruent to 0 mod 6, right? Like this is clearly true, right? 6 and 0 are both divisible by 6. So I can say this is true. And then if I were to like kind of subtract 2 on both sides, I can kind of say 4 is congruent to negative 2 mod 6, right? I'm just subtracting 2 on both sides. So if 4 is congruent to negative 2 mod 6 and x is congruent to 4 mod 6, like you can kind of say like x is congruent to negative 2 mod 6. And with like a similar reasoning, you can say like from as x is congruent to 3 mod 5, you can convert that to x is congruent to negative 2 mod 5, you can kind of say. So like if we were to combine these 2 congruences together, remember how we would do that is we would take the least common multiple of 6 and 5. So we would get x is congruent to negative 2 mod the least common multiple, which is 30. So now we can easily find that the smallest value that works is x equals 28, since 28 and negative 2 are both congruent modulo 30. So now we go back to the question. Since now we know that the box originally contained 28 pieces of, or 28 gold coins, we want to know how many coins are left when we equally divide these coins among 7 different people. So, but we know 28 is like divisible by 7. So that tells us that the remainder would just be A, 0, which is the correct answer.